Hari Om. Let us continue solving some questions from continuity. In this question, we have to check whether the function f of x is equal to mod of x minus 3 is continuous at x is equal to 3 or not. So before we proceed, we should know something about this type of function. If f of x is equal to mod x, so we can write it as f of x is equal to x if x greater than 0 and minus x if x less than 0. So whenever x is negative, so whenever this part becomes negative, the answer is minus of that. And whenever this part is positive, the answer is same itself. So accordingly, let us try to break this one. So f of x is x minus 3. When will this part be negative? So x minus 3 less than 0. When will this be possible? If x is less than 3. So our critical point is 3. So we can write this as if x is less than 3, then this part will be negative and the answer will be minus of x minus 3. That is 3 minus x. And when x is greater than 3, greater than or equal to 3, this part will be positive. So we will have same as it is. This is how we are going to break this function. So instead of this function, we will be using this one. So our function is, let's write it here, f of x is equal to 3 minus x if x is less than 3 and x minus 3 if x is greater than equal to 3, or if x is equal to 3. So if x is equal to 3, 3 minus 3 will be 0, so the value will be 0. This is our f of x, and we have to check if this function is continuous at x is equal to 3 or not. So for that, we have to find LHL, RHL and f of a. So let's find LHL first. LHL is limit x tends to a minus f of x. Here a is 3. So limit x tends to 3 minus, and 3 minus means left of 3. That is x is less than 3. So we have to use 3 minus x. Now while solving LHL, what we do is we substitute x is equal to point, that is 3 minus h. So let's substitute. So limit h tends to 0, 3 minus, instead of x, 3 minus h. So this becomes limit h tends to 0, 3 minus 3 plus h, or limit h tends to 0, h, that is 0. By substituting 0 in place of h, the value of LHL is 0. Similarly, RHL, limit x tends to a plus f of x. So limit x tends to, the point a is 3 here, so 3 plus, and if x is to the right of 3, that means x is greater than 3. So we have to use this function x minus 3. Now while solving RHL, we substitute x is equal to point plus h. So this becomes limit h tends to 0. Replace x with 3 plus h. So 3 plus h minus 3. So this also becomes limit h tends to 0, h, which is also 0. So LHL is 0, RHL is 0, and f of a, that is f of 3, is when x is equal to 3, the function is 0. So since LHL is equal to RHL is equal to f of 3 is equal to 0 at x is equal to 3, the given function is continuous at x is equal to 3. Alright? Okay, now let us proceed to the next question, which is somewhat similar to what we did earlier. Now we have to find the continuity, we have to check the continuity of the given function at two different points. So before we start, we have to first write the function in that different form. So here you can see that we have 2 points, 1 and 2, which are critical. So this will be negative if x is less than 1. This will be negative if x is less than 2. So we have to take 2 points. So if x is less than 1, then if x lies between 1 and 2, and if x is greater than 2. These are the 3 points we have to take. 3 parts we have to take. So if x is less than 1, then this will be negative. So the answer will be minus of this. So 1 minus x plus. Similarly, if x is less than 1, this one will also be negative. So answer will be minus of this. So 2 minus x. Now when x lies between 1 and 2, so x is greater than 1. That means this is positive. So it will be as it is plus. X is less than 2. So this will be negative. So it will be 2 minus x. Similarly, if x is greater than 2, this will be positive. This will also be positive. So x minus 1 plus x minus 2. So our function becomes, this will be 3 minus 2x if x is less than 1, and here x and x will cancel. 2 minus 1, 1 if 1 less than equal to x less than equal to 2, and 2x minus 3 if x is greater than 2. So instead of this function we will be using this one, and we have to check the continuity at x is equal to 1 and 2. So let us first start with at x is equal to 1. First of all, we have to find LHL, RHL and f of a. So the LHL will be limit x tends to a minus f of x. And since we are calculating at x is equal to 1, the point is 1, so a is 1. Limit x tends to 1 minus f of x. Now for 1 minus, we have to use a function. 1 minus means towards the left of f1. That is, x is less than 1. So when x is less than 1, we have to use this one. So 3 minus 2x. Now in order to solve this, in case of LHL, we apply x is equal to point minus h. So 1 minus h. Let's substitute that. So limit x tends to 0. 3 minus 2 times, instead of x, substitute 1 minus h. So this will become limit h tends to 0, 3 minus 2 plus 2h. So limit h tends to 0, 1 plus 2h. Now if we substitute h equals to 0, our value is 1. So LHL at x is equal to 1 is 1. Similarly, let us find RHL. So limit x tends to a plus f of x. So limit x tends to 1 plus f of x, and this is to the right of 1, just to the right of 1. So x is just greater than 1, that means it lies in this part. So 1. So without any further calculation, we can directly write the value as 1. Now f of a, that is f of, our point is 1, so f of 1. When x is equal to 1, the value of function is 1. So here you can see that LHL is equal to RHL is equal to f of a. So the function is continuous at x is equal to 1. So f of x is continuous at x is equal to 1. Similarly, let us follow the same procedure for x is equal to 2. And as you can guess, it will also be continuous. So at x is equal to 2. Now our a is 2. Let us find LHL. So limit x tends to 2 minus. Now to the left of 2, just to the left of 2. So we have to use this one. So 1. Without solving, we can write this directly as 1. Similarly, RHL will be limit x tends to 2 plus, and to the right of 2 means we have to use this function. So 2x minus 3. And how do we solve RHL? We substitute x is equal to point plus h. So let's do that. Limit h tends to 0. 2 into 2 plus h minus 3. So limit h tends to 0. 4 plus 2h minus 3, or limit h tends to 0. 4 minus 3 is 1 plus 2h. Now if you substitute h equals to 0, you are going to get 1. So LHL is equal to RHL. Now f of a, our point is 2, so f of 2. So when x is equal to 2, the value of function is also 1. So since LHL equals to RHL is equal to f of 2, f of x is also continuous at x is equal to 2. So the function is always continuous. Alright? Okay, coming to the next question. Here we have been given that the function defined like this is continuous at the point x is equal to 5, and using that we have to find the value of k. So since the function is continuous, as you know that LHL should be equal to RHL should be equal to f of a, and our point here is 5. So a is 5. So let's find LHL first. So LHL is limit x tends to, the point is 5. So 5 minus and f of x. So 5 minus means to the left of x. So x is less than 5. So we will be using this function kx plus 1. And how do we solve LHL? We substitute x is equal to point minus h. So 5 minus h. So let's substitute. This will become limit h tends to 0. K in place of x, 5 minus h plus 1. So limit h tends to 0. 5k minus kh plus 1. Now if we substitute h is equal to 0 here, this will become 0 and we will get 5k plus 1. This is the value of LHL. Let us find RHL. RHL will be limit x tends to 5 plus, and if x is greater than 5 means to the right of 5, we have to use this function. So 3x minus 5. And while solving RHL, what we do is we put x is equal to point plus h. So 5 plus h, let us put that. So this will become limit h tends to 0 3 times. Instead of x, 5 plus h minus 5. So limit h tends to 0, 15 plus 3h minus 5. So limit h tends to 0. This is 10 plus 3h. If I substitute h is equal to 0 here now, the value will be 10. Now f of a. Our point is 5, so we have to find f of 5. And in which case out of these two x is equal to 5? So x is equal to 5 in this case. We have to use this function. So that is k into x is equal to 5 plus 1. So this is 5k plus 1. Now since the function is continuous, so LHL is equal to RHL is equal to f of 5. So LHL is 5k plus 1 is equal to 10 is equal to 5k plus 1. So by solving 5k plus 1 is equal to 10, 5k will be 9. So k is 9 by 5. Alright. So with this question, let us stop here in this part. We will proceed to some more questions of continuity in the next video. Thank you.